You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoy the podcast, please listen, subscribe, like, and share it with friends. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast. I have Louise Charles. She's the Communications Director at Climeworks, CLIMEWORKS, Climeworks.com. Louise, thanks for coming. How you doing?
Very well. Thank you for having me on.
Yeah, tell me about Climeworks, which I guess is short for Climeworks. But what's the premise of the company?
So first, it's not quite short for Climeworks. That's another company, actually, an NGO based in the US. So they are a customer of ours, but they're not actually related to us in any way. But the background of Climeworks is that we were founded about a decade ago by two mechanical engineers, Jan Wurzbacher, Christoph Gebold, and the company was originally founded as a spin-off from ETH, so the Swiss Federal Institute for Technology here in Switzerland. The two founders did their PhD theses on direct air capture, so capturing CO2 directly from air. And we've grown into a company of 70 employees since then.
Okay, so I had read the background a little bit. So direct air capture, I don't know if you could describe the process, but it works to take CO2 out of the air directly and store it, I guess, underground or in other appropriate places?
That's right, yeah. So the way it works, very simply put, is that we build machines. We call these machines CO2 collectors. And the way a CO2 collector captures CO2 from the air is that we have a fan on the one side, which draws air inside the collector. Inside there we have a filter material, which is highly selective, so it captures just CO2 on its surface. And you can think of the filter material a little bit like a sponge. So if you were to dunk a sponge into a bucket of water, then the sponge would fill up with water. And essentially the same thing happens with our filter material. So it fills up with CO2. And once it's fully saturated, we close our CO2 collector. It's heated to around 100 degrees Celsius, and the CO2 molecules thereby unstick from the filter material and can be collected. And once we've collected the CO2, there are various things that can happen to it. So on the one hand, we sell that CO2 on for use in raw materials, for use in products as a raw material, And there it's sold either to the drinks industry for drinks carbonation, to greenhouses for use as an airborne fertilizer, to producers of renewable fuel. So they are all off-takers of CO2 as a raw material. So either the CO2 is recycled, if you like, in a product, or we take CO2 and with our partners currently in Iceland, the Carbfix team, they take our CO2, they mix it with water, they pump it deep underground, about 700 meters, and there is a chemical reaction between this hot fizzy water essentially, and the basalt rock that's beneath Iceland, and stone is formed. So the CO2 is mineralized and thereby permanently removed from the atmosphere. So these are the two use cases for the CO2 that we capture.
So in Iceland, are you doing the capture locally and then the storage locally, or do you do the capture and then ship it to them in Iceland?
No, everything's done locally. So there we have a pilot plant in Iceland, and it's capturing CO2 from Icelandic air and is stored locally. And that's the beauty of direct air capture, and that these machines can be built anywhere. There is a renewable energy source. And if we then want to store that CO2 that we capture, then we need some sort of a storage option as well.
What are the economics of Iceland doing this? Is it buying the CO2 from you then and storing it? And how would the economics work for the country?
So in Iceland, what we currently have there is a pilot project. So it's a small installation. We have one of our CO2 collectors out there, and this stage is operating within the framework of an EU R&D project, so Horizon 2020, and is funded through that.
Well, since CO2 is generated all over the world, by many different emitters, it just seems like, I guess it'd be an interesting thing. I wonder if countries could choose to invest in a direct air capture investment that resides in another country, because it still, I guess, would benefit, that country or offset its emissions. So it seems to open up like an interesting economic model, if possible, if, given countries who are interested in that. Mm-hmm. Created one place, gotten rid of in another, it paid for disposal, essentially.
Mm-hmm. Yeah, that's exactly right. So the beauty of this carbon dioxide removal is that it's relevant worldwide. So it's exactly as you say, one can in one part of the world emit that CO2, and in another part of the world then remove that equivalent amount of CO2 from the air and store it underground.
Are there countries that are willing to pay for this more than others? I mean, there's who would be a big payer or buyer of this kind of service, or is that part of the trouble that people are happy to emit and no one wants to pay to have it sequestered?
Thankfully, slowly things are changing. So there are both corporations and NGOs, philanthropists, and newly also individuals who want to physically remove their CO2 emissions from air through direct air capture and through the combination of direct air capture and the underground storage of CO2. One of our very first customers for carbon dioxide removal was a father-son couple. They were planning an expedition to the South Pole and wanted that expedition to be totally carbon neutral. And we're of course aware that by traveling to their starting point for the expedition, that through those flights there were emissions that were created, and they wanted to remove those emissions, and so came to Climeworks, and we were able then to capture that same amount of CO2 from air in their name and store it underground.
What's the approximate economics if if an individual person says, "Hey, I want to buy a certain amount of storage"? What does that look like? Is there literally pricing for the public if they wish to do something, or for corporations?
Yes, there is. There's pricing for the public. What we quite recently launched was a web shop, which is Climeworks.Shop, and there we enable individuals to remove their travel emissions. And there's various pricing options. It's a subscription model, and there's three different options that can be chosen between. The first starting at €7 a month, and the higher one at €49 a month. So depending on how much CO2 you want to be removing from air, then there's the corresponding price for that. And bespoke packages are also available.
So what do it's a good thing that they'd be doing, but what do people get? Let's say if they're going to commit to a subscription of removing a certain amount of carbon every day for a period of time? Do they get some kind of recognition or, I don't know, maybe even a credit from their government, a tax credit or something? Or, if a corporation does this, individual does this, are you working on any systems like that as a reward?
We are, yes. So the individual choosing to purchase one of these subscriptions receives a certificate at the end of the year. And there it's clearly stated how much CO2 was then removed in that individual's name per year.
Any interest from particular countries on, setting up something like this with all their citizens? It could be a good or a bad thing or good or bad, method, but a tax on all their citizens that maybe is weighted depending on their age or their use or their family members or just the fact that they're a citizen of a given country. And that would be, the person would pay again to offset their emissions.
Conversations are ongoing. Can't say anything too concrete yet. On a slightly higher level than just for the storage, we have various governments very, very interested in direct air capture and supporting the further development of direct air capture technology. Amongst them is the Swiss government, German government also, and there are more and more governments very, very keen on exploring how they can help support the development and optimization of direct air capture.
So what are some of the numbers involved? If there's a big push for solar and wind use and other renewables, will direct air capture be needed in order to stop climate change? Or what are some of the big numbers that you've seen that talk about what's going on?
The big numbers. It depends a little bit which source you take, but one often cited source is the IPCC, so the Intergovernmental Panel on Climate Change. They last October they came out with a report called the SR15, or the Special Report on 1.5 degrees, and there it outlined what the world will need to do to keep temperature rise beneath 1.5 degrees. And there was very clearly stated that on the one hand we'll need a portfolio approach, so there's not one solution that will be enough to solve it on its own, and Climeworks is very much of that opinion as well. We cannot do this alone. We're just one of many solutions, but that IPCC special report clearly said that emissions on the one hand need to be reduced and drastically reduced, but that's not enough to make those climate targets. And so on top of that, we will also need to be physically removing CO2 that already is in the air, and that's where direct air capture comes in.
Well, I'm sure there must be natural sinks of carbon, on the Earth. Mm-hmm. Even with those natural sinks, is it still? All these things still need to be done in order to prevent a worldwide temperature increase of above 1.5 C.
That's right. Yeah, that's right. So that brings me back to this portfolio thinking. So we very much need those natural carbon sinks, and we need to be preserving them so that they can function as they should in the years to come. We also need trees. We should stop cutting down trees. We should be planting more trees, and alongside that also further develop these technologies, amongst which direct air capture is one. Further develop them so that they can scale to the levels needed. And this IPCC report, again, the numbers there are huge, and it's many billions of tons of CO2 per year that will need to be removed directly from air to stand a chance of making those climate targets.
Can direct air capture be done using renewables? Can you run a gigantic direct air capture machine using solar or wind or geothermal, or does it have to be unfortunately traditional sources?
No, we explicitly only use clean energy, so only renewable. We have 14 direct air capture projects across Europe currently, and they're using a mix of, some use geothermal, some use solar, some use wind, We have two installations that are using energy from waste. So they sit on the top of a waste incineration plant or garbage incineration plant, and through the burning of the rubbish, energy is generated, and we're able to harness that energy to power our direct air capture machines. So we do not use conventional fossil-based energy for our direct air capture.
And is there I'm sure it varies, but what's like the ballpark cost per ton to sequester carbon, or, is it per cubic meter? Like what's the the metric by which they use to define it economically?
Mm-hmm. So the cost to Climeworks currently to capture, just the capture part, capturing 1 ton of CO2 from air is around about $600. The storage part is a fraction of that, so $15 or $20 of that 600. And the long-term cost target that we have is to bring 1 ton of air captured CO2 down to $100.
What about the emitters themselves? Big commercial enterprises that emit CO2. I would think the concentration that they emit is, hundreds, thousands, millions of times higher than ambient air. They probably have scrubbers, but is there an incentive to make smaller units that could be bolted on to existing emitters, for a fee where you could really capture like a whole bunch in a nice concentrated spot?
Mm-hmm. So there, I think what you're referring to is point source capture. So there,
right.
Climeworks is not in any way involved in point source capture. So we focus really on direct air capture only, so directly from the air. And this portfolio approach that I mentioned earlier, point source capture also has its role to play in there. So also important technology that should be developed further and used worldwide. But with point source capture, yes, the concentrations are higher there of CO2, about 20% compared to 0.04% of CO2 in ambient air. But there we cannot remove CO2 already in the air. So they're preventing newly emitted CO2 from entering the atmosphere. But with point source, you cannot go carbon negative. So you cannot remove historic CO2 emissions, if you like, from the air. So you would achieve at best carbon neutrality, but not go carbon negative.
You were saying that it's not possible to, I guess, am I understanding that right? It's not possible to get the CO2 down to the levels needed in the direct area around an emitter, around a point source?
Yes, no. You in the air surrounding it, yes, you could. In theory, you could have traditional CCS equipment on the flue gas stack capturing the newly emitted CO2, and a few hundred meters away you could have additional direct air capture machines which are capturing CO2 already in the air. So in theory they could be combined in that way.
Yeah, I don't know.
CO2 is different. So the point source is really from flue gas coming directly from the factory, let's say. Whereas direct air capture, these machines you can build them anywhere, and they're removing the CO2 from air, from ambient air.
Gotcha. Has Iceland noticed any local effects, or have any other countries that have the direct air capture machines noticed what happens in the immediate vicinity of the plant? Does anything happen different? Because there you're going negative essentially versus the ambient on the amount of CO2 in the air. Is there anything that they notice that happens to the local flora, fauna, anything, people in the area, or is it nothing special happens?
No, there's some negligible impact there, and CO2 diffuses so fast in the atmosphere that the concentrations are more or less the same worldwide.
It's too bad if it felt really good to be right there, and the air somehow just felt a lot better, and people experienced that. That's what I was hoping.
I think that may be to do with the other natural surroundings there and lack of large cities and heavy industry. perhaps.
Yeah. Like in a greenhouse, it kind of feels like that. So that's what I was wondering, but oh well. So are the economics such that, you said that these plants are powered by renewables, which is great. So, how many theoretically could be built, should be built, and at what scale, and how much will this contribute to, reducing our carbon emissions to the right level? Like, what's the future hold for Climeworks? How much more needs to be done?
What the future holds, time will tell. What needs to be done is a large scale up. So in the last decade, we have achieved quite a nice scale up. So when our founders first began, they were in a laboratory setting at the university, capturing just a few milligrams of CO2 from the air. 10 years later, we're now building large industrial direct air capture plants, which are capturing many thousands of tons of CO2 from the air. So the scale up there has been nice, and the challenge lies now in replicating that same scale up. So going from building plants that capture thousands of tons to plants capturing many hundreds of thousands or even millions of tons.
What's the anticipated timeline on being able to really have a large plant and to scale this whole effort up?
So we have a goal, admittedly very ambitious goal, of capturing 1% of global CO2 emissions by 2025. So that's the star that we are following, if you like, for now. And once that's achieved, then the scale up will continue, and we will do our best to scale direct air capture to the scales needed to become then truly climate relevant.
Is there any worry that as you guys get better at doing your job, that other countries may not see what you're doing and say, look, things are getting better, we don't need to try as hard? It seems like you'd have to really trumpet what you're doing so that no one gets the idea that things aren't as bad and let their foot off the gas, essentially.
Yeah, that's very much something we've been very aware of in the last years, and we refer to it as the moral hazard. But there, especially with various climate reports having come out, the IPCC that I mentioned earlier being one of them, they're making very, very clear that it's not an excuse to keep emitting, and that really to make these climate targets, we need to drastically reduce emissions, and on top of that also remove CO2 from air. So the urgency is being better and better understood worldwide, and less being used as an excuse to continue to emit.
That's great. Any ancillary technologies or add-ons that you see are in the lab but will be maybe available soon to help this effort?
Not from Climeworks side. We will continue to focus on our direct air capture for now, but it will be further developed, further optimized. We have 8 generations of the technology planned. We've brought 2 of them online already, and with quite short innovation cycles, hope every year to be coming out with a newer version or an optimized generation of direct air capture technology. So keep an eye on the Climeworks website.
Okay, very good. And the best way for people to find out more is what? Go to climeworks.com. Anything else? That's
right. There's climeworks.com with general information about the company and the various uses for that CO2. And for those interested in turning their own CO2 emissions into stone, then they can go to climeworks.shop, and there they'll find all the information they need.
Well, that's great. Well, Louise, thank you for coming on the podcast. I appreciate it.
Thank you very much for having me.
You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription. or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and share it with friends. Thank you.